We load the dataset, separate the data between the target and explanatory. If we visit this website from Keras official documentation, we can see all of the available optimizers and the theory behind them if we click on these links. In our case, we will use the stochastic gradient descent, the RMS prop, and the ADAM. In the Python codes, everything remains the same. The only thing that changes is the optimizer. Within the Keras, we import the optimizers, and now we can see for the SGD that we can copy and paste it here. In this case, the optimizer is a class. I cannot use it without the parentheses, otherwise it will give me an error. So I place the parentheses because sometimes we may want to change these parameters within the optimizer, although in this tutorial we won't get into the details. Now we execute. The predictions remain the same number, 15, although it is a good signal that the predictions are near to the reality and probably the model has converged. If we evaluate the model, we get an error of 16, which is quite good. If we look up the dictionary, we can see at the beginning having an error of 88,000 and then decreasing rapidly. Now we will use ADAM, which is an acronym for Adaptive Moment Estimation. In the optimizer, we can use the module and get inside to use ADAM. Place the parentheses, execute. Now the predictions are different, contrary to the SGD, where all of the predictions were the same number. Some of them are close to the reality. If we evaluate the score, we get 134, which is not so bad. Now we try the RMS prop, which stands for root mean squared propagation. In the optimizer, we look inside the module for the RMS prop, place the parentheses, although we could have also used the string, and we can delete the parentheses and the optimizers. The predictions now are way better than the ADAM, since they are closer to the reality, and they also vary and not remain the same number as in the SGD. We evaluate the model and get a score of 9, which is the best we have gotten so far. Now if we analyze the improvement of the error across the epochs, we observe how the SGD at the beginning started with a really high error, and then all of a sudden we got a small error, which improved over time. Nevertheless, the predictions we get from the SGD remains the same one, and that is why this optimizer is not feasible for this data. On the other hand, we have the ADAM optimizer, which at the beginning starts with 11,000 in the error. It quickly reduces the error with only 30 epochs. Nevertheless, as we increase the number of epochs, the error remains above 100. On the other hand, if we use the RMS prop, we observe how the error takes longer to reach a convergence point until 100 epochs. Nevertheless, it is better at 100 epoch than the ADAM. The ADAM had an error at 500 epochs above 100. Nevertheless, with only 100 epochs, the RMS prop has an error of 45. And finally, at the end, we get an error of only 10. As a general conclusion, it's not enough to reach a minimum convergence as soon as possible. Also, the error must be minimized as much as possible, and we should also look up within the prediction so that they don't remain the same. because of these many configurations that we have at our disposal in deep learning, you can consider that creating neural networks is an art that very few can understand, but with this course you are right on track. In the following tutorial, I will show you how to work with the loss functions, which is a parameter that we have in the compile function.